Welcome back, everybody. It is Wednesday, January 28th, and we get to start right off by finding the factored, simplified, and sketch of the following function. So we're going to go through, and today we're starting with the following. I'm going to give you guys a couple minute head start. This is collaboratively with your neighbors or myself if you're struggling with things. So we're going to graph. Ooh, how gross do we want it? Okay. Well, this one works really well for a question that it's the other way around. That's okay. Here we go. X squared plus 2x plus 1 in the lovely numerator here. And we're going to divide this bad boy by a cubic. X cubed minus 2x squared minus 3x. So, for this, remember, there's a few things that I can check with this problem, and it means that these problems are really easy. We don't need a ton of them for me to assess like where you're at. You have to be able to factor to do these problems, and then once you factor it, you have to be able to make sense of definitions to decide where all your asymptotes and key feature stuff are. Then you actually have to graph it. Cool. Talk it out. I'm going to give you guys a head start. I'm going to be walking around for assistance if needed. Don't just sit there and wait for the graph to show up, because I'm sure it will. Obviously it will. We're going to go through it. But if you don't know how to do it, don't just wait on me to do it and say, oh yeah, I know how to do it because Holloway can do it. Doing math is really easy if all you're doing is following along. Making it yourself is much more challenging. Practice the challenge, embrace it. Cool, so we'll go like 5-ish minutes. We'll see how long it takes, but I want you guys to start working through this together, right? Meow. That doesn't work still. But I'm gonna go to my factored form and I'm just gonna write it out. The numerator, does it factor nicely? Yes, and I'm gonna write it instead of x plus 1 squared, I'll write it like this. Did anybody here recognize it was a perfect square and you just right away said x plus 1 squared? Cool, awesome, if you did. If you didn't, did the shortcut take you here? Awesome, if you don't remember the shortcut, but you remember grouping, which would be weird, did you get here? Yeah, I don't know if anybody actually grouped it or not, but the denominator, there's a tricky piece. What comes out first? X. Now, when I do that, and I'm just thinking out loud right now, I'm not showing all the scratch work, x squared minus 2x minus 3 is what's left. Factors of -3 that add up to -2. -3 and 1, right? Okay. Right now, what is this? Like this form of my equation? It's factored. Okay. So we have the original, now we have the factored, and there's something that's going to come out of this form, but there's one more form that I want you to write. And I guess the big question is, what is the difference? I'm going to call randomly here. What is, Seabass, when did you get here? No, don't gaslight me. Do you have a note? Or did you give a note? Okay. Was I standing there? Not sure if you're gaslighting me still, but we'll survive. All right. I didn't register at all. I was so focused on the math. All right. Weird. Like, for real that happened? Bizarre. Check this out. I don't know any of your eye colors. If you ask me, like I could look at you in the face for 20 minutes, and if you ask me, 100% chance I'm going to think to myself, they have dark hair, it's probably brown. Like 100%. I don't know any of your eye colors. I'm the least observant person on earth. But that's okay, because number 15, who dat? Oh, it's me. Hey, Sonny. What's the next form I'm going to write, and how do I get there? So I went from the original to the factored. There's another form that I'm going to write here in just a second in red. Oh, standard, right? I wouldn't call it standard. But if you can read the directions, you'll probably be able to reason out what it is. Hey, there it is. Awesome. So how does it simplify? Hey, x plus 1s. Now, before I just rewrite this, I see this happens. Anything important that this tells me? Where does my function have a hole? How did you know it was at -1? Okay, so there's a bunch of ways you can say this. Notice I'm not going to make a point out of it, but I know that the root from this factor, which is just setting it equal to 0, x equals -1. So whenever I draw my graph, this is the most frequent place that I make mistakes with mine. When I draw my graph, I'm going to do it solid, and then after the fact, typically, I go back and I erase a little part and make it a hole. Or if you're more on top of it, you can just do it throughout like the actual graph. I pretty regularly forget. So my most factored or simplified form rather is x plus 1 over x times x minus 3. Now, I did not write them, I don't think. Are there parentheses in my numerator? Right now, there's physically not. but there are, right? There's grouping that happens, and that's a really important distinction. This is its own factor, and the reason that I stress that is because if you're making mistakes, what is somebody going to do wrong if they don't recognize that it's its own factor up there? What mistake would somebody make here that is really easy to make and reasonable? They're going to cancel and divide out the x's, right? But you can't because you can only do it if it's a whole factor over a whole factor. If we include these parentheses, we avoid that mistake. Worth doing. Now, from here, we have so much of our information, and we can get the rest of it. Vertical asymptotes. How do I find vertical asymptotes, number 17? And the what's good? The zeros of the denominator. How many factors do we have in the denominator right now, Elijah? Eli, weird. Why did I call you Elijah? That was weird. Say it again. How many factors in the denominator right now? Are you saying 3 because you can count 1 and 2 and 3? So I see that there's 3 terms down here, but there's 2 things being multiplied, right? 2 factors, which means if I have 2 factors in the denominator, how many vertical asymptotes am I going to find? 2, 1 for each root. And this is always a weird question, what value of x makes x 0? 0. And that's such a strange question, but it is. What value of x makes x minus 3, my other factor in my denominator, 0? Positive 3. We have 2 wonderful asymptotes. What else should I, go ahead. The whole, from when we divided this out, and I'll just do a little bit of scratch work here. Good question, Kennedy. To get the whole, it comes from this step. And when I see that x plus 1 was my factor that divided out, if you set it equal to 0, help me solve this for x. Yep, so we subtract 1, x equals negative 1 was the root that divided out instead of the word factor. That's how we get it. Okay, horizontal asymptotes. Saw a lot of people make mistakes because one of the 3 possibilities is crazy easy to deal with. Anybody say on your page right now that the horizontal asymptote is at y equals 1? I know exactly what happened. Unfortunately, I don't agree with you, but let's see if, it's totally get why. Why would somebody say y equals 1? Because I saw a lot of people do it, more than just 1. You're trying to do the leading coefficient thing, which is good. Like your head's in the right place, almost. What is the degree of the numerator? It's a squared. What's the degree of the denominator? 3, or cube. Who gets bigger faster? The denominator. Cubes grow faster than squares, like way faster. Now, if we think about that, if we pick a really, really big number, it's kind of big, way bigger. If eventually for a big enough number, way, way, way bigger. So we essentially get to a point where we're at smallish number over gigantic number. If I offer to give you guys 1/1 trillionth of my net wealth, are you psyched about it? Ouch. Why not? You shouldn't be. If I was worth $1 trillion, which I'm not, that would be $1. I'm nowhere near a trillion. 1/1 trillionth for all intents and purpose is pretty much how much money? 0. Which means for a big enough number, what value does this get really close to? 0. Now, if you want to logic your way through it, we can, and it's nice and easy. Or did we ever write if the degree is the numerator is bigger or equal or smaller? Do we ever have that written down somewhere nice and concise? For sure. Turn back like 2 pages in your notes and you will see it. That is the sort of thing that I would strongly recommend for note cards. If you're going to retake your quiz, I guess not really there because we weren't using it as much. But let's knock it out. So what do we just decide? The numerator gets kind of big and the denominator gets really big. What's some number over a really, really, really big number? 0. There's our horizontal asymptote. Now, for the last little piece, how do you find, and I'm going to be very consistent with this, it's really hard for me to not write roots, just so you guys know. Like super hard, but because we use that language everywhere else, we're going to commit here. When's a fraction 0? Number, syntax error. No? Okay. 25. When is a fraction equal to 0? When the top is 0 or the bottom is 0? What are we not allowed to divide by? So the bottom can't be 0 because that breaks it. So there's only one more option. The numerator is where we need our 0. 0 over something is where we get 0. Is there a value of x that makes the numerator 0? What is it? Negative 1. All right. So I'm going to write this as negative 1, 0. The zeros of the numerator. Now, with all of this, the graphing part, this part seems okay for most people. Is this easier than the graphing? Okay, so I'm going to introduce something today that if we need it, you can use it. I'm kind of all about efficiency. I try to do things fairly quick and not maybe to a fault sometimes, but let's graph this. And if you are struggling with the logical connections here, it's okay because we can always just get a few extra little pieces to put on the graph. So let's see where we need those pieces. And I'm just going to look, am I more left or more right based on all of this as far as x values go? So what's the furthest left I go? So I need to go a little further than that, right? Because I want to see to the other side. How far to the right do I go according to any of these? So Lando, back to you. Am I more right or more left? If I go all the way to 3, so I'm more on the right, but I need to go a little bit to the left. So I'll say I'm focused on the right here, but not like a crazy amount. Now, if you haven't been doing it, I would encourage you should make sure that you have the axes labeled so that if when we draw our asymptotes, we don't confuse ourselves. Gentlemen, question over there? So give me another word for x-intercept. No, I know where you're looking, but give me, there's 4 equivalent terms that we use or words. X-intercept, root, solution. What's the last one? 0. When we find an x-intercept, do you agree it's somewhere on this? No matter what x value I find, what's the y value? That's how I know it. Yep, so my gut, I really want to write x equals -1 for that part, but I don't want it to look exactly like the asymptotes is the only reason I'm changing that format. But it is a valid format nonetheless. Okay, for this, help me pick my scale. How far to the right do you think I should go? So at least a 3. Do I want to see anything on the other side of that asymptote? Or do I only just need to go to the asymptote and see a third of my graph? I probably want to see all of it, right? So I need to go past 3. I don't care how far past 3 we go. 5? Sure. There's 5. Now, which means, and this is not, I would have picked 6 personally, but 5 is fine. So I'm going to eyeball 1, 2, 3, 4. That was much better than I was anticipating. Those all look pretty consistent. Okay, how far to the left? I can probably go to 3. I need to go a couple past that. If you want to do a big square thing, go all the way to -5. Cool, do it. I don't think we need it, but you can. So let's see, I'm going to go, I don't know, we'll just keep it consistent. I can go to -1, -2, -3 about is where I can get with my scale. Now, from here, I've not done any y values yet. And we don't really need them unless we want a nice graph. What could I put on here right now before we commit to y values? Let me rephrase. What information from here can I put on the graph? I can't do the hole yet. I need the graph to know where the hole is going to be. Can I put these? Can I put this? Can I put this? So almost all of this. So let's do that. I have a vertical asymptote, or rather 2 of them, at 0, which remember I would advise and suggest just do it a little bit to the side. You guys use dash lines. I assume, I hope you are. I'll make it bold so I can tell that here's an asymptote. Am I ever going to touch this one? No, never, never, never. So I'm going to make that a little smaller so we can label it. Here's x equals 0. And the other one's at 3. 1, 2, 3. Here it is. Now, there's a few ways that we can think about this. X equals 3. And let's see here. Okay, so a couple questions that I have. I don't like that those are different, but we're just going to ride with it. Looking at this, how many sections is my graph going to show up in? So I heard 6 and I heard 3. 6, I assume you're looking at top and bottoms. I'm only looking on the x-axis. How many different regions or intervals did we cut the x-axis into just now? I put 2 cuts. If you have a piece of bread and you cut it twice, how many pieces of bread do you have in front of you now? 3. So there's 3 regions, right? Weird idea. I'm glad that that resonated with you. So I need 3 regions of graph. Okay, well, let's start figuring them out. At this point, we've done this, the vertical asymptote. I'm going to do the horizontal asymptote real quick. It's just the y-axis. Scratch that. We'll do that again. Am I allowed to cross a horizontal asymptote? Yes. Yes, it only tells me about how my function behaves where? At the end. Now, it's not quite at y equals 0, and I know that, but it's so we can see it. Okay, anything else that I can put on this graph before we start figuring out what additional points we might need? Now, is there anything weird about trying to put my x-intercept on? It's going to wind up being a hole. Now, with that in mind, if I know that it's going to be a hole, but I want to put it on the graph, do we have a way to represent that point on the graph still? An open dot at which x value? -1. There it is. There's the hole in my function that I'll never touch. Sonny, not a coincidence that we looked at that briefly before class. Okay, it's a weird situation. It's okay. Now, beyond this, I don't know what the graph does. Do you guys agree with that? Now, there's a couple ways we can organize this, and I don't really care the way that you do it, whatever's more comfortable. I need, I don't know, probably like 2 or 3 more points realistically to get a good graph. Do you want me to make a table like we've always done, or do you just want to do f of x and pick some x values and plug it in there? So they're the same thing, right? Just in the end. It doesn't matter which way we format it, and I'll demonstrate that so that if you'd rather do that, a table instead, I'm cool with it. So this last little piece, we haven't done this, but if we're struggling with the graphs, and this one is kind of an ugly one, I'm going to add one more little piece where I'll just call this some extra points. And we're just going to work these out. Now, I get the choice. I can plug in to whichever version of this f of x that we want. Do you think I should plug into the original, the factored, or the simplified version? Why? It's going to feel like a silly answer, but I'm going to agree with you, I bet. Why the simplified version? It's simpler to work with. Yeah, 100%. So check it out. First question that I just want you guys to write on the margin. We claim there are 3 regions or intervals. On the margin, off on the side, what I want you to do before we graph this is identify the 3 intervals. And what I mean by that is I go from -infinity to where, and then another one goes from, I don't want to say it, but in your margin, write the 3 intervals that I see here, 1, 2, and 3. Give me the x ranges that those things are at, or the domain of each piece. X range is a terrible way to word it. I go from -infinity, and if anybody doesn't know what I'm asking, please let me know and I can clarify. Check it out. So you only have one asymptote. I'm going to look at yours. I start at -infinity. Where's your second one? The dash. Oh, okay. I just didn't see it. Do you have a y-axis? Or y equals 0? So check it out. I start at -infinity, and I start going to where? Where does it get weird? 0. So our first one is -infinity to 0. The next one is 0 to where? 3, and the next one is 3 to 3 to infinity. Good. I'm going to call, who wants it? Okay, I'm going to call you. All right. What do you guys think? Do you understand the question that I'm asking? What are the 3 intervals? So can I point at this? So check it out. Do you agree that this cuts my x-axis into intervals? The first one starts at -infinity, and where's the first place I go to where it gets weird? 0. So -infinity to 0, and then 0 to, and then 3 to. Those are the intervals that we're looking at. Okay. All right. Eli, intervals. What do you think? What are these 3 intervals? I start at -infinity and I work to where? To 0. Notice, and you guys don't need to shade, but what Eli just spotted was there's a whole region over here where I need to know what the graph does. That's that first one, -infinity to 0. Mark, where's the next one? From 0 to 3, we should probably know what's going on. So I'll just shade that one here. And again, you don't have to shade it. I just want to make this very clear. And there's a bigger reasoning behind this. Last one, Julia. 3 to infinity. My graph is going to occupy each one of these 3 regions, somewhere in here. Now, our job is to decide where is it. That's all that we have to do. Which means when I'm trying to decide extra points, I think I know what this function is going to do, but we're going to check. Looking at it, we need something over here. And I need to know, does it go above the axis or below it? That's all really I need to know. Pick anything in this first yellow region, any x value. -2 is a good choice. Why not -1? It's undefined there. Good. So if we're going to pick a couple different points, and yellow is a terrible choice, I'm going to use orange so we can see it. You guys said -2. All I need to know is what's f of -2. When I plug in a -2 into my function, what y value does it give me? That's my point. So let's check it. If I plug in a negative 2 up here, what does it give me? Negative 2 plus 1 is negative 1 over negative 2 times negative 5. Positive 10. Which means this is really, negative 1/10 is fine with me, but you might prefer decimals. I don't think it's positive because we had a negative times a negative. Right? Negative 2 times negative 5. Okay, so negative 1/10. If you want a, it's not an approximation, it's exact. What is that as a decimal? Negative 0.1. Okay, I'm going to graph that point. At negative 2, I'm at negative 0.1, which no scale yet, but it's a little bit below the axis. Do you guys agree with that? Okay, is that enough to tell me what's going on with this graph yet? On this yellow region? For some of you, it might be. For others, it might not be. If we want another point, that's okay. Give me another point in this yellow region, and we can use it. So 3 would work. I have a feeling it's going to be just closer over here is my gut. Is there another point that maybe, like, I know that it has to settle here, right? And let me rephrase that. How do I know that it's never going to cross again? I know that it settles here. So there's 2 good ways. What was yours, Amy? It's never going to cross the x-axis again because it only happens one time. Good. The other way that I know it is, what is this horizontal asymptote? Tell me again. So I know that in the end, I get really close to this value. This is the only way I can do that. I can't shoot downward. Now, I would like to know, because I think that arguably it could do something wonky elsewhere. Can you tell me a value in this little range? Negative 1.5? I don't think that'll do it. Negative 0.5? If we try this, and I don't really care a ton about the number, but if we can't tell exactly what it's doing, and this is where it gets weird, I'm going to check. So I'm not going to get the real number. All I care about is the sign. Because if it's positive, I know that it's going to do something like this, and then settle out back over here, somewhere there. Or if it's negative, something wonky happened, but we'll figure that out also. Don't need the true number, I just need the sign. So let's look. Negative 1/2 plus 1 is what? Positive. Okay, now it's positive 0.5, but notice I don't really care that it's 0.5 if we're just sketching. What about the denominator? Negative 1/2 times a negative 2.5? Or negative 3.5? But it was a negative times a negative is the most important part. We just said without a doubt that it is at positive 0.5. With that in mind, I know that it passes through these 2 points and through that hole, and it has to do something like this. Only option is it crosses through, and I'm going to make that a little nicer. Crosses through. How do I know it doesn't do this all of a sudden? Good, there's only one x-intercept, only one place it can happen. If it can't turn back down, what's it got to do? Goes upward. Now, over here, why doesn't this work? That last little addition, why does this not work for my graph? So this doesn't cross the axis. What are we going to get really, really close to at the end of this graph? 0, right? That's the horizontal asymptote. I can't shoot downward to infinity. Now, I might do a weird little hiccup like this. I don't know for sure. But since we're just sketching, what I do know is it's going to have to get really close to 0, but it'll never touch again. Okay, this section, the purple section, and I'm going to sound like a broken record, and we're going to say this about 1 billion times. How do I know it doesn't cross the x-axis in that purple section? Why? My goodness, there's only one x-intercept, only one place it can ever cross the axis. Well, that means everything is either above or below in the middle, right? I don't know which one it is. What x value can I pick in that middle interval? 1 is a good choice. Cool. Let's pick 1. Now, I'm going to move these just so they match up because you guys elected not a table. I'm okay with that. These first 2 were to check this interval. I'll just try to keep them organized like that. So if we're going to check 1 in this other interval, let's give it a go. So if I wanted to do f of 1, let's see what we get. What's 1 plus 1? 2 over, let's see, 1 times negative 2. 1 times negative 2 is negative 2, and maybe this is what you were saying, negative 1. Okay. I think that this, just this, locks me in here. I just said at 2 it's at -1. Now I'm going to try to stay consistent. What was this y value that we marked here? I didn't even write it. Does anybody remember roughly what it was? I see Naomi calculating it out again in her head. Okay, so I think it was around 0.5. Pretty sure it was around there. Now, what I know is if I'm just looking at scale, if that was 0.5, I'm going to try to be consistent. Is that about twice as far? Maybe a little too much, huh? Either way, when I plug in a 1, I get -1. I know it's negative. I want you guys, really roughly, sketch what the graph does in this middle purple interval. Do it on your page, lightly, so if it's wrong, we can fix it. But I want to see where your head's at. Doesn't have to be perfect. I just want a quick sketch of what that middle section must do. So, are you getting lost here?
What does the hole mean?
So the hole is there's an open point here. It's actually not defined. This is a big open circle. And it is on mine. I'll make it more clear there's an open circle. Our function just is not defined here.
But like, what does the hole mean?
It means our function is not defined here.
What do you mean by that?
We can't plug in -1 because, remember, we divided out. It made us divide by 0.
But we couldn't even, we can't never do that though, right? If the x-intercept is negative.
So, and that's why it's weird. So this is conceptually, when we say x-intercept, and I keep using this language, I've kept using the phrase, does it cross the x-axis, right? So it doesn't really touch it, but does it cross the x-axis there? Yeah, so it does cross over. Like we've identified that point. It just happens to be undefined. So the only way to make that happen is to have a hole there. Only way we can change from positive to negative if we don't want to touch the axis is to have a hole or an asymptote. Like we'll clean that up. Do this part for me though. If we said it was negative,
it has to stay in this, right?
it has to stay in the middle. So plot this point here that we just did, f of 1, -1. So plot that point. And then here's my, yep, I'm cool with that. Here's the important question. Is it ever going to cross the x-axis here?
No.
So if it's already below the x-axis, it's going to be below everywhere. What was wrong with your graph, that one?
Oh, just go like this?
I don't know.
Love it. It can't turn like this. Why?
Because it can't cross the x.
So what must it do? If it can't turn up,
It just goes straight.
so it can't do this either because it's going to cross the
it
axis.
just goes back
It
down.
must turn down. All right. Coming in here, I'm just going to glance really quickly. Love it. Watch that, though. Do you know what I was pointing at? Make sure that you don't cross this. And I don't think you're going to. Love it. Love it. Lando, you're erasing, and I'm cool with that. Why are you erasing? What do we know it's only going to happen at -1? The only time this graph is ever going to cross the axis is at -1, right? But you show it graphing here. Love it. Do you understand why this is it?
Nope.
So let's logic it, and I'm going to talk it out. Okay, coming through. Most people have this pretty solidly. Quick question, and again, broken record style. Where is this function going to cross the x-axis? The only place. We've already done it, right? If it's negative here and it can't cross the x-axis again, it's going to stay what? Negative. So I can't cross the x-axis, so I know it has to go downward like this, gets really close to the asymptote. Why can't it do this? It can't cross the axis because there's how many x-intercepts? So if it can't turn up like that, what must it do? Turn down. Now, I don't know if it's really a nice parabola like this. It could be something wonky like this as well, as long as it doesn't touch the axis. But all we're looking at is the basic sketches of these things. Has to be something like this. Okay, I think right now I'm pretty confident on what the outside looks like, but it could be either all the way above or all the way below. How do we decide which one of those it should be? Seabass. So over on this side, it has to be like a parabola. Now it could be like, I can show you and we'll look at the actual graph. This does exactly what I know the function is going to do. Could it do something wonkier like this though? And I wouldn't say that this looks like a parabola anymore, but this is equally valid for now without the extra points. If we don't get all the extra points, I would say keep it simple. Especially since we're just sketching. If we wanted to do 2 and figure out exactly where it is and 2.5, we could. But I guarantee that all the points are going to be negative, and it's essentially going to do this. Show me what you mean a straight line. So it can't. It has to be a little bit slanted because it can't be truly vertical, but it'll get really close on here. You're okay. All right, this section, all I need to know is above or below, because if it's above, it's never going to cross. It's always above. If it's below, it will never cross the axis. It will always be below. So that means I just need one singular value here. F of, what would you like me to plug in, Liam? 5 is a fair choice. If we plug in 5, let's just check. 5 plus 1 is 6 over 5 times 2. 10. That's 6/10. Now, I don't really care about the 6/10 if we're just sketching. What's the part of that that I really care about? At 5, it's at a positive value. Is it ever going to do this? How do you know? It only has one intercept. And I know I'm stressing that like crazy, but that is like the important idea here. There's a reason I'm doing it. If it can't cross, it means it must turn upward if I go this way. So it must do something like this. And if it can't cross, but I know it gets really close to 0, it must do something like this over here. Now, for those of you that were not as vocal and you would have preferred a table, I just want to show you real quick. Before I do that, Ronaldo, do you have a question? Over here? Love that question. Okay, this is an open question. Ronaldo asks this, and it's a great question. I'm going to give you guys 30 seconds to decide who's going to speak real quick, and then we'll do the thing. Do we do that in here yet? Decide who talks and who listens? Okay, so do that real quick, and then I'll pose a question. Decide who is talking, who's listening. I haven't given you the question yet, so that's the tricky part. All right. Do we have winners at groups? Or you're figuring it out? Here's my question that I want you to address. 30 seconds. Whoever's speaking, you're going to explain this. Ronaldo asks, how do I know the function mellows out here? Why can't it do this? That's the question. Why can't it? And if you didn't see what this was, let me get rid of these so it's a little bit clearer. I'm going to make it like obnoxiously bold. Why can't it do this? 30 seconds. Talk it out. One of you talk it out. I'm going to listen. Love it, love it, love it. What do you think? What? So it's okay if you don't know. Is there? I'm going to tell you the answers here. What does this thing tell me again? And what is that? So you're right. It is 0. But it's the end behavior. What do you guarantee this graph gets really close to as we go far left or far right? Yeah. The horizontal asymptote tells me the end behavior, and you guys make it a habit. I see you skipped it here. Use y equals. Like, make it a point to do y equals and x equals for your asymptotes. I will take off half points, just so you know. I know it gets close to 0. Check it out. There's, how can we do this? How do I know that that doesn't work? Anybody have a good answer? Ha! End behavior. What do you mean end behavior? Ha is my hint. What about ha? The horizontal asymptote, and I know that that's what you meant, Michael, just for the record. The horizontal asymptote tells me the end behavior. I know that I can't see it on mine, but the horizontal asymptote, or if I word it differently, the y value that we get really close to at the ends of our function, what do we find it to be? Does this get really close to 0 for the y value? No, that's not doing what we said it would. It has to get close to 0. The only way to do that is to get close to 0. Cool. Make sense, Ronaldo? Great question. All right. Today, we have like 10 minutes left. We have one section remaining. Now, there's one little piece in here that, depending on how this goes, is going to dictate how we go through it. These sections are big. There's a lot of material in here. And if you're not 100% comfortable with it right now, I get it. The good news is that we do this next year in pre-calc again. The first 3 chapters of pre-calc is essentially, let's review all of Algebra 2 really quickly. Like, it's all review, so if it's not perfect now, that's okay. Now, as we're looking at this, we have one more type of problem that I want to do, but before, I want to see, nobody's asked for a brain break. Okay, real quick, yeah, now that I mention it, what's happening? Just so you guys know, with like rough planning, today we may finish this. 100% depends on this. If we don't finish it today, tomorrow is going to be a split day where we do some work and then we get a new lesson started. I am planning, hopefully, team test Monday. Team test. So the review or practice test Monday. Okay, this one. Here we go. What's up? Nope, this is an example. Yep. Okay, so for this, we are going to multiply rational, this Q remembers rational, expressions. Now with these, here's the weird part. Remember, I goofed up and we jumped ahead of a section, and what wound up happening throughout that is all of these we had to wind up doing anyway. And there's nothing crazy about it. We didn't do any additional instruction stuff. I just want to see what you guys come up with before we go really hardcore into it if we don't need to. So without any additional guidance, you guys have multiplied already, but I'm going to give you a lovely product to work out for me. Am I being nice or not? Okay. I mean, I might. I don't know. All right. So here we go. I want you to do the following. And with 3 minutes left, realistically, this will probably be your assignment in the notes. At the start of class tomorrow, I'm going to come around and check, and I'm going to hold myself to it. Finish this problem. You are supposed to, or you will this evening rather, we're going to take the rational expression x cubed minus 4x divided by 6x squared minus 13x minus 5. But I want you guys to multiply this by 2x cubed minus 3x squared minus 5x. Now, I'm going to give you a huge piece of advice, and I'm just going to put some really big annotations in here. And before I just write it, let's just check. Anybody have a first gut feeling on what you might do to try to, why would you factor? To see what's common, right? Holy cow, I want you to factor everything as step one. Factor it all. The other little piece that I'm going to mention once I write this, you're going to factor everything. Second piece, and I'm not going to write this one. The left expression, this one, very clearly a fraction. Like there's no doubt. Is this a fraction? It's not written as a fraction, but it is. How? It's over 1. Cool. You might use that. Your assignment in your notes, you're going to do this problem. I'm going to check tomorrow morning. I'm going to put this as a homework. Thanks. Maybe. I don't know if that's a compliment or not. I'll be less generous for you, Angel. I got you. All right. Finish this. Cool.